look at, but I'm going to give you a couple more. So let's start with the one we know, hopefully. Reflecting over the x-axis. This is our most basic graph, y equals x squared. We looked at it yesterday. Okay, you should know what that looks like, and if you don't, it's pretty easy to plot it. Just put on your x and y table. Okay, I want to reflect this. First of all, what does that do? Well, quickly, let's find out. If x is -2, this is a little confusing. Let's write that out. Negative x is -2. It's x squared with a minus in front. So you got to do that. Okay, x is squared. If x is -2, you have to put the brackets there, right? Okay, so -2 squared is 4, but now it's -4. If x is 1, I have -1 squared, which is -1. If x is 0, I have 0 squared is 0. What's -0? Still 0. X is 1, I got 1 squared, but now it's -2. I got 4, but now it's negative. So, I'm just trying to use a different color, but I guess blue will be fine. -2 is -4. 1, sorry, that was supposed to be a -1, right? -1 is -1. 0 is 0. 1 is -1. Okay, and you can kind of cheat here and go, well, this thing's symmetrical. So that point's also going to be here. And what happened? Got flipped is one word, but this is now Math 12. There's a better way to explain that. It got reflected over what magical line? Yeah, this is an x-axis. It got reflected, here it is, over the x-axis. That's what we did last year in Math 11. This, do you know we have a Shuswap teacher now in the school? There's actually a Shuswap course we're teaching. That's Shuswap. It actually means, in English, it's translated as also known as. Acha. Okay, anyway, there's a couple of different ways we can write this. This is the thinking when you actually have to graph this in x and y points, right? You got to think, there's brackets there. But let's think algebra. Can I divide the -1 away? Whatever you do to one side, do to the other side. Is that the same as this? Because this, we haven't really looking at it like that before, but now we want to. So that actually is going to make more sense, because we got a whole bunch of other stuff going on. And it gets rather confusing. Okay, so we all agree that's the same thing? So think of it this way. Whatever you got for y before, let's say it's this point up here. Now it's -y, which means it's the exact same point, but now it's down here. It's reflected over the x-axis. Okay. So, in pre-calc 11, we looked at the idea of placing the vertex and determining the direction of opening. Another way of looking at this function is to multiply the y values by -1. All the y's now become negative. Gets flipped over. And I actually made you memorize that in Math 11. Again, when we're looking at this general function, that's vertex or standard form in some textbooks. Other ones call it general, so it gets all confusing. But I said, we got to investigate. Okay, yesterday we did this and this. P makes it go left or right. Q makes it go up and down. And then we got a little confusing and said, well, let's put Q over here. And then, well, it's going to do the same thing, but we got to think about looking at it with a different sign, right? Then we introduced A. We spent about, I think, 2 days on this, just looking at what A does. So today, all we're looking at is the sign of A. We're not looking at the magnitude. But remember, if A is a big number, this parabola actually shrinks. It gets skinnier. We called that a stretch. If A was if A was larger, greater than 1, it actually became fatter and wider. Okay? So we're not doing that today. All we're looking at is the sign. But I made you memorize, if that thing was negative, then the parabola had a maximum, right? It opened down. Okay? So that's exactly what we're doing right here. Okay? Or multiply all the y values by negative, it flips it over, reflects it over the x-axis. It's been reflected over the x-axis. And I might even have said that, but flip works in grade 11, okay? Because we only kind of flipped it in one direction. Now we're going in all sorts of different directions. This is our new graph, y equals root x. Here, Austin knows the books. You're here? You're in this class?
Yeah.
All semester?
Yeah. Oh,
Good job.
well, it's okay.
You probably should do the rest.
What, you shouldn't be too many colors, though. I'm not really-
You what? You can't see red? You cannot see red? Okay. Thanks for telling me. There's another kid. Who was that? Who? Yeah. Oh, I remember who it was. I'm not going to say his name, but yeah. About, 3.5 months into the course, I'm looking at it and I said, well, you're trying to help him with a question and doing the notes. And I'm like, you didn't even write down the notes. Well, I can't see him. I'm like, what do you mean you can't see him? Okay, he was sitting at the back. Move at the front. Well, no, I can't see the color red. I did the whole semester in red pen, and he tells me now, like, okay, thanks for letting me know. Blue it is. And you could always move closer too, right? Too bad. Get a new pair of glasses. Okay, that's root x. Not quite as familiar, but again, can we quickly plot this thing? What are a couple of nice values for x? Well, you got to ask yourself, do I know the square root of some nice things like 0? What's the square root of 0? 0. Do I know the square root of 1? X is 1, then y is also, the square root of 1 is 1. And then I probably want to go up to 4, because I know the square root of 4 is 2. Okay, and then the next one I probably want is 9. If x is 9, y is 3. So this is 10, so that's 9, so that's 1, 2, 3. Okay? So that's what that looks like. It's already there for us. Now, what does this thing do when I put a minus in front of it? Yeah, so we don't really want to plot this, and like I may make a mistake like I did yesterday. So what does the minus do? The thinking is quickly it reflects it over the x-axis. So if I want to reflect that over, do we see brown? Okay, good. Maybe my daughter should use that. Then she wouldn't have an excuse to not pick up the dog food. Anyway, it's symmetrical about the x-axis, right? So that point's there. This point is going to be here. That point is going to be there. And it has an arrow. It doesn't just stop at 10. I know it looks like it, but there's an arrow there. Keeps going forever and ever and ever in the positive direction. Okay, speaking of which, what's the domain of the original function? I won't ask Lewis. He's allergic to domain. He doesn't see domain. Or range, actually. Okay, who can tell me the domain of this thing? Yes, thank you. Okay, all the positive values. In English, that's what that says. The range is the same thing, because it goes from here, 0, all the way up to positive infinity, which is a term we used a lot when I was a kid. Oh, not X. Y is all real numbers, right? We just put that. It's all the fractions, decimals, everything you could possibly think of. Again, from that line to that line is an infinite amount of numbers, right? Because I can always go 5.1, 5.11, 5.111, right? So that's why we put this. It's not just whole numbers, not just integers, okay? Anyway. This guy, how does the domain change when I flip it over the x-axis? No, it doesn't. I don't really care. So in my brown, x is also still greater than or equal to 0 and all real. Range, does the range change? Absolutely. And I'm sure there's some kids out there who actually memorize this, and it wouldn't be bad. I'm just not that type of person. Okay? When I have some graph f of x and I reflect it over the x-axis, the domain doesn't change, but the range does. Wonderful. I would just prefer you to just kind of think for 8 seconds, make a tiny little graph, and figure it out. Okay? But I'm sure there's people out there who do that kind of thing. So the range now, y is less than or equal to 0, all real. Okay? All right. So we've done what this negative does, but we haven't seen a graph like that. In general, what kind of a graph do I want? Negative 7 and 6. Put a point there. Negative 5 and 2. Put a point there. Negative 2 and 5. Put a point there. And then make a nice curve. There's some graph f of x. Try putting that in your graphing calculator. Good luck. Okay? Again, it's general. There's not specific numbers here. But that is some graph f of, you know what? Let's get crazy. Ooh. Let's go h of x. That's h of x. What? You can't use h. Yes, I can. Okay? Now, how do I sketch a graph of, let's change that. How do I sketch a graph of this? Minus h of x. Well, if you remember that, you're going to maybe get a mark in your quiz tomorrow. What does it do? Reflects it over the x-axis. Could I also put the minus over here? Yes, I could. The minus is on the y. It's the y that's going from positive to negative. Can we see green? So you got 3 points. Take those points and reflect them over this mirror. Okay? Because if that was a mirror and this were you, this brown curve, it would look like you would be here. Exactly. The same distance away from the mirror, right? That's a reflection. Okay? I don't care about the general shape here. I know that's not perfect, but I got my 3 points are perfectly reflected, correct? Okay? Sometimes it helps too. I say this in Math 11 Foundations, which none of you guys took. But sometimes they look at their textbook and they're visualizing all these angles and they can't see it. And all I do is grab their book and I turn it 90 degrees and they go, oh, there it is. Okay? So visually, sometimes it helps to do that. And I'll tell you in a sec how that's going to be even more helpful. But if you turn your head sideways, do they look exactly the same? Does it almost look like a Rorschach card? What do you think of? What's the first thing that pops into your mind when you see that? I see an angry wife chasing me with a rolling pin. Rorschach. I don't know. I'm going off on a tangent. Okay. Some point. Psychology. These are in psychology, right? So which is, sorry? I'm not familiar with that term, but I'm sure it's the same thing, yeah. They show you pictures and, you know, when you're having some psychological test when you're 4 or 5 years old, because maybe you just decided to pick up your dad's gun and shoot your baby sister, they would put you through some tests like this. And they're all angry thoughts, right? Everyone watched The Grinch with Jim Carrey? And you know, the little Grinch, he's drawing cartoons of Santa Claus getting blown up by missiles. And okay, that's not a good sign. Right? Anyway, this isn't psychology. This point is on this graph. What point? Well, what is the transformed point after it goes through that transformation? You got to know what is that transformation. And if you can draw the point, then you can visualize it. Okay? How does the domain change if you reflect it over the x-axis? It doesn't. See, it might be helpful if you memorize that. How does the range change? Well, it gets flipped down here. It is now negative. Okay? In general, some big honkin' relation, and again, I'm not a math specialist. I would just call that a function, but I guess technically, someone says, I don't want you to see red. Someone says, this is not a function, this is a relation. And honestly, I don't know the difference, but don't worry, it's not going to be on your test. Okay? But in general, what does that do when you put a minus on the y? Oh, I hate to sound like a Baroque on a record, but it's a reflection over the x-axis. The only thing that happened here was y was replaced with negative y, okay? Reflection over the x-axis. Okay, kind of seems easy, but again, when we got this on top of 6 other things and translations and up and down, it gets a wee bit confusing. Okay, that's one way. Now, Math 12. Let's go over the other axis. Here's our graph, y equals x. I already plotted that. You know what that looks like. If that's reflected, well, I'm telling you what it does. Do you believe that just by looking at the picture? Or does that kind of look like what we just did? What we just did is not that. It was that. And I know that looks really similar, but it's something completely different. This minus can be taken and put on the y here. Can this one? No. Quickly, plot that in your head. If you put in positive values of x, what happens? You can't do it. That only works for negative values of x. Green. That's this graph. Make sense? That's definitely a reflection over the y-axis. And I know that's pretty confusing because it looks pretty close to that, but it does something completely different. Okay? So, my original function, again, x greater than or equal to 0, x all real. The range, y greater than or is equal, y all real. This new guy, well, if you're a memorizer, did my domain change? What are the x values of the green graph? X less than or equal to 0. Those are the only things that are going to work here. Because again, think of restrictions in Math 11. Some of you guys love that word. You can't take the square root of a negative. Positive values of x here will make this thing negative. You can't do it. So only thing that's going to work are negative values of x. Make sense? If you got the picture, you just look. X is still all real. How does the range change? Does the range change when you flip it over the y-axis? Doesn't look like it. Okay, I'm not a memorizer. Like I just said it, I'll know it for about 8 seconds and then it'll be gone. Okay? I'm not good at memorizing. I just draw the picture and figure it out. In general, okay, let's go -5 and 5. Let's go -3 and 2. And let's go -1 and 4. That's a graph of y equals f of x. Graph y is f of negative x. Got to know how to do that. It's easy now because I'm teaching it. And you know you're in the section called reflection over the y-axis. But you got to understand the difference between that one, okay, and that one, or that one. Looks completely different. Is the minus on the y or is it on the x? It's on the x. That's a reflection over the y-axis. So that point becomes there, that point becomes there, and this point becomes here. Okay? I didn't plan on making a strange picture there, by the way. I don't know. Okay. This point then, on y equals f of x, if I do that transformation on it, what is the new point? Does the domain change? Does the range change? No. And if it helps, if you can plot it, well, feel free. I recommend it, okay? Reflection, that's on the x. That's a reflection over the y. That means it's over here. Yep, that's minus 2, 3. Okay? In general, if x is replaced with negative x everywhere in this relation, what happens? That's a reflection over y-axis, okay? So we got 2 reflections. Let's give you a third. Reflecting over this line y equals x. Aha, also known as y is f to the minus 1 bracket x bracket. What does that thing say? That says this. That says inverse. Before someone asks, that is not reciprocal. And some of you are fresh off reciprocal. Some of you knew how to do it, and some others didn't. This is not the same as that. That means 1 over f of x. This is not reciprocal, this is inverse. Something completely different. Okay? So forget about that. Let's just plot this. If I have y equals root x, that's what I have. If I swap x and y, what happens? And now the thinking's a little bit different. And again, how the heck would you put that in your calculator? Well, it's kind of easy. You just solve it for y. But remember, when you square both sides, well, that's fine, don't worry about it. Okay, so you could plot that, but how would I graph it? And you got to think kind of backwards. First of all, this guy, what's the domain? I've done this 3 times now. Let's do it again. This guy, let's do a quick little x and y table, but do I want to put in values of x and then figure out what y is? Or do I want to think kind of backwards here and put in values of y and figure out what x is? I think I want to do that. Because if y is 0, I know what the square root of 0 is. If y is 1, I know what the square root of 1 is. But now it gets kind of, I don't want to put in x and try to figure it out this way. I want to go that way. If y is 4, what's x? So let's see what this looks like. Okay, I can use blue. So 0, 0, x is 1, y is 1. X is 2, y is 4. It's going up that way. What's another nice value of y? Y is 9, x is 3. Let's actually even plot it backwards. Y is 9, x is 3. What happened there? That's a reflection. A reflection over what? There's your clue. You all know what the line y equals x looks like? Good, you should. Just like y equals x squared, you should have a mental picture of that. But if you don't, it only takes 8 seconds to figure it out. If y is 0, x is 0. If y is 1, x is 1. If y is 2, x is 2, and so on and so on. If x is negative 3, y is negative 3. That's the line y equals x. Is that a reflection over that line? Turn your head 45 degrees. Definitely is. Okay? Or turn your book. If you look straight down that line and put your head with your eyes like this, that's how our brain wants to work, right? You ever tried watching TV upside down? It's like you can't even recognize the people on TV. Okay? Put your eyes right on that line. Visually, that's very helpful. You see it's a mirror right here. This is a mirror image of that reflected over that line. That is inverse. That you have to remember. Okay? Inverse means a reflection over this line. Written as an equation, you also have to know that means inverse. So lots of stuff to put in your noodle. Okay? Any questions? What's the domain of my new graph? Does the domain change? I'm not saying it's always a rule, put it in your head, but in this case, it still goes out forever and ever and ever from 0. It's the same. Does the range change? Starts at 0, goes up forever and ever and ever. Looks like that doesn't change either. So again, that may be not a rule you want to try to memorize, but in this case, it didn't change. Okay? So, when I take y equals f of x and I do that to it, who's a quick memorizer? What does it do? Good. That says inverse, reflection over the y equals x line. First of all, I need a graph. -1 and 6. +2 and 3. 0 and -1. And let's do one more point. Let's go -3 and -2. Okay? And then make a graph. Y equals f of x. So how do I reflect that thing over a y equals x line? Because visually I can maybe kind of figure that out. And again, some people are better at this than others, right? Some people become good drivers. Other people, their insurance is really expensive. Well, remember I did this? If I just swap the x and the y, that happens. So that's how I'm going to graph this thing. Okay? Visually, if you can think you can do that, be my guest. If you think you can reflect that thing over this line. But here is your foolproof, sure way of doing that. Let's look at this point here. That was -3 and -2. If I flip those places, I get -2, -3. Does that look like it reflected over that line? Sure does. This point was 0, -1. If I swap x and y, I got -1, 0. And that's a reflection over the y equals x line. Take the next point, 2, 1, 2, 3, and swap those, and I got 3, 2. And the last one was, looks like -1, 6. So now it's going to be 6, -1. Now join them as best you can. And then visually check. Because while you may get it close, it's going to be awfully hard. Believe me, that's a lot quicker than trying to do it just freehand and then erasing. Note that one looks off, that one looks off, okay? Don't even try. If you got some strange graph, not just a point, that's how we do it. We just swap x and y, okay? Look down that line. Does that look like a reflection over the y equals x line? It should. Then you want to double check, because you might have made a mistake plotting your points, because everybody does, right? Okay? So, when I swap x and y, what does that mean? You got to understand. That is inverse. Okay, and that is, I'll just write the same thing again, doesn't hurt. Reflection over y equals x line. Okay? This all means the same thing. There's 4 ways to say it. You got to know all 4 ways. Because you can't ask me, Mr. Watson, what does that mean on the test again? What's that? Sorry. Can't tell you. You got to know. Okay? So, some strange relation. If I show you this and say, this is what happened, then you tell me, hey, that must be inverse. Reflection over y equals x line. How does the graph of this relate to that? Inverse. Okay? Any questions? Last little summary page for you, which may be helpful. This is what we did. What did this thing do? When I have a minus in front of that, well, ask yourself, can I write it like this? Yes. So the minus is on the y. That is a reflection over the x-axis. This minus here can't go on the y. That's a reflection over the y-axis. And this thing, which can be written a different way, is inverse. That's over the line y equals x. Okay? That's it. Quiz tomorrow. Welcome to the class, Austin.